Hi there. In this lesson we're going to be talking about errors, residuals and deviations. Now before we go any further we have to make a number of definitions of things because there's a lot of confusion about the kind of terminology that we should be using. So to make sure that we're all on the same page, we all understand exactly what we're talking about, I'm going to make these definitions. Okay, so the first one is observation. We're going to define what observation is. Observation is something that you measure, and that could be height or weight or something similar, or it's something that you count. It could be the number of males, number of females, or whatever. Okay, so the observation is something that you measure or count. Prediction. Prediction is a statement about a future event, and you get such a statement about a future event from a statistical model like a univariate regression or a multivariate regression, or you can get such a statement from a machine learning algorithm, so from an artificial neural network. All of these things are these give you predictions about what it is that you're trying to predict. Okay, error, the word error. This is the difference between an observed value and the unobservable true value. Okay, so what is this unobservable true value? Well, let's think about this in terms of you're measuring somebody's weight. You're measuring your own weight, okay? So you get up in the morning and you get on your scales and you measure your weight. Okay, that's the true value, isn't it? You just observed it. Well, no, because you then go downstairs and you have your breakfast and then you can stand on your scales again, and now you're going to get a different value for your weight. And of course this difference is the weight of the food that you eat, isn't it? Actually no, it isn't, because as you're eating it you're metabolizing it, so it's not. So the weight before your meal, the weight after your meal, the weight at various different points through the day as you do exercise, you have a walk to work, you sit around, you do things, you eat, you drink, it varies a lot. And so this thing about this true value, it's a myth. When we're talking about events, when we're talking about measuring things, it's very rare that you can have an observable true value of something. Things vary. If you want to calculate the length of a metal bar, you think it's fixed. It's not. If this metal bar is hot, it's going to be a different length to when it's cold. So it varies, and this is what happens. So the true value of something is usually unobservable, and if you can't observe it in an individual, then you can't observe it in a population either. So this thing about a true value is a myth. It's a theoretical construct by which we say we want to try to get as close, we want to get our prediction as close to this true value as we possibly can. The only problem is we don't know what the true value is, and we probably never will know what the true value is because it's unobservable. But anyway, you will see this term being used quite a lot when we're talking about predictions, and most of the time the term error is being used incorrectly. So this is why I want to make sure that we've got these distinctions. So the difference, the error is the difference between an observed value and the unobservable true value. So if somebody's talking about we've calculated the error, no they haven't. They're using the term error incorrectly. Okay, let's move on to the next one. So here we are. The error is not much use to us because the true value is unobservable. Deviation. Deviation is the difference between the observed value and some other value. Yeah, that's a bit ambiguous. This some other value, it could be, it's what we define it to be. So if we talk to other people about deviation, we have to define exactly what that some other value is. And if we don't, then what we understand to be deviation could well be very different to what they think is the deviation. So the term deviation itself is too ambiguous. So I'm not going to be using the term deviation, or at least if I do, give me a slap around the face because I'm using it incorrectly. Okay, next one, residual. Residual is the difference between the observed value and the predicted value. Now that's good. We like this because we have an observed value already. It's the value that you measure with a ruler or a stopwatch or a jug or some weighing scales, whatever. That's the observed value. The predicted value is the number that comes out of your predictive model. So we've got numbers for these things. So residual is just right. It's the thing that we're looking for. We don't talk about errors. We shouldn't be talking about errors because it's unobservable. We don't talk about deviations because it's too ambiguous. But we do talk about residuals. And actually, out there, when you go and read around these different statistics, you'll find that people are using these terms interchangeably and they're using them incorrectly. And even in these lectures, I will be using the word error, as in mean error or root mean squared error. And it shouldn't be. It should be mean residual or root mean squared residual. But I'm doing that because nobody ever talks about the mean residual, even though that's the correct term. They talk about mean error. It's a misnomer. They're using the term incorrectly. But if I use the correct term and you go out there onto the internet and you start reading around, you'll think, what's he talking about? What I'm talking about is how you should be using these terms and actually out in the real world, the real usage of these terms, so you know the difference between what is correct and what is. They may well be using the statistic correctly, but they've named it incorrectly. But anyway, we're going to move on. Okay, so here we are. Here is a graphical representation of the difference between an error and a residual. So we have our true value and our observed value, and the difference between those is the error. And of course, remember, the true value is unobservable, so the error we cannot do anything about. But the residual, remember the residual, the meaning of residual is something that is left over. That is the difference between the predicted value and the observed value. And we can work with that, and actually that is what we work with when we're dealing with predictive models. It's all about the residuals. Okay, that's enough of definitions for now. I hope you've got the understanding of each of these different terms. If you get confused at any time, come back to this lecture and go through it again, and hopefully you give yourself a bit of a refresher. Up next, we're going to be talking about residuals and how to calculate them.